We have already seen the Fourier series of 12 periodic even and odd function defined in the interval, defined over the interval minus L to L. And we have already seen example for an even function. Now consider an example for an odd function, a 12 periodic odd function defined over the interval minus L to L. What do you mean by an odd function? If f of minus x is equal to minus into f of x, then it is said to be odd. If f of minus x is equal to f of x, then the function is even. Okay? Then find the Fourier series of f of x is equal to x, where minus 2 less than x less than 2. That is, the function is defined over the interval minus 2 to 2. Comma, f of x is a 4 periodic function. Given f of x is a 4 periodic function. That is, f of x plus 4 is equal to f of x. Now, f of x plus 4 is equal to f of x. A 4 periodic function. Okay? And then problem we take first number and the period identify here. That is 12 periodic function defined over the interval minus L to L. That is minus 2 to 2. Okay? That means the given is a 12 periodic function defined over the interval minus L to L. Okay? Then what is f of x is equal to m? X. What is f of minus x? F of minus x is equal to x minus x, that is minus x. That is equal to minus into f of x. Minus into x means f of x. That is, f of minus x is equal to minus into f of x, or the given function is odd. That is, f of x is equal to x is a 4 periodic odd function defined over the interval minus 2 to 2. Then the corresponding Fourier series, the Fourier series is the Fourier sine series. The Fourier sine series is given by f of x is equal to sigma n 1 to infinity bn sine n pi by l x, where bn is given by bn is equal to sine n pi by l x, where bn is given by bn is equal to 2 by L integral 0 to L f of x into sine n pi by L x dx. Okay? Again, what is the period? 2L is equal to 4 periodic. 2L periodic means here 2L is equal to 4. That is, L is equal to 2. L is equal to 1 bn sine n pi by 2x. L is equal to 2. That is, bn is equal to 2 by L. That is 2 divided by 2. 2L equal to 4, that is L is equal to 2. That is 2 by L, 2 divided by 2, integral 0 to L, 0 to t. F of x, what is f of x? F of x is equal to x into sine n pi by L means n pi by 2 x dx. And 2 by 2 is equal to 1. Then apply integration by parts or the product rule. First into, this is first, the second. First into integral of sine. What is integral of sine? Minus cos n pi by 2x divided by n pi by 2. Cos 5x into integral minus sine 5x divided by 5. Then minus cos n pi by 2x divided by n pi by 2. Between the limits 0 to 2. First into integral of second minus integral of 0 to 2, integral 0 to 2. Derivative of x into integral of second. Integral of second means integral of sine minus cos n pi by 2 x divided by n pi by 2. Okay? Then that is bn is equal to, okay, n pi by 2, here also n pi by 2, n pi by 2 is outside. N pi by 2 outside is 1 divided by n pi by 2, outside 2 divided by n pi, that is 2 divided by n pi. Here minus, this is also minus. Then or minus 2 outside, minus 2 by n pi. Minus 2 divided by n pi. Upper limit apply to x into 2 cos n pi 2 by 2. X in power 2 and 2 cancel. That is 2 cos n pi. Minus lower limit apply x equals 0 by 10 and the above 0. Minus this minus integral 0 to 2 cos n pi by 2 x dx. Integral cos n pi by 2 and sin n pi by 2 by n pi by 2 between the limits 0 to 2. Second, that is equal to E2 that is minus 4 by n by minus 4 by n by cos n by. What is cos n by? Cos n by is equal to minus 1 raised to n. Here, apply upper limit. Apply upper limit apply cos into 2 sin n by 2 by 2. 2 to cancel back sin n by. X in 2 കൊടുത്താൽ ഈ 2 താഴെ 2 cancel sin n by. What is sin n by? Sin n by is equal to 0. Minus lower limit sin 0. Sin 0 value 0. Then ഈ രണ്ടാമത്തെ ടേമിന്റെ ഇന്റഗ്രൽ വാല്യൂ ഓഫ് ദി സെക്കൻഡ് ടേം ഈസ് 0. ഈ ലിമിറ്റ് ബാക്കി എന്ത് വരും? minus 4 divided by n by into minus 1 by 0. That is Bn is equal to minus 4 divided by n by if n is even. Assume that n is even number, then minus 1 square, minus 1 raised to 4, minus 1 raised to 6, etc. 1. That is equal to minus 4 divided by n. Then next assume that n is odd. N is odd means 1, 3, 5, etc. Then minus 1 cube. The minus me minus 1 plus I. That minus 1 raised to 1 I plus I. Minus 1 raised to 5. That minus this minus to multiply that plus. And that is equal to Bn is equal to 4 by n by if n is odd. That means in this representation B1, B3, B5, B6, etc. are 4 divided by n by n. B2, B4, B6, etc. are minus 4 divided by n by n. And then Bn is equal to minus 4 by n by or 4 divided by n by n. That is common 4 by pi common. That is the Fourier sine series this one. F of x is given by f of x is equal to sigma n 1 to infinity. And that means B1 sine n pi x by 2. N pi by x by 2. And then B1 sine pi x by 2. B2 sine 2 pi x by 2. B3 sine 3 pi x by 3. B4 sine 4 pi x by 2. B5 sine 5 pi x by 5. It's very 2. Then what is B1? B1 is equal to the n order 4 by pi. The 4 by pi into sine n1 pi x by 2. N in the value 1. What is B2? B2 is equal to n even minus 4 by n by n. Then minus 4 by pi outside. Then sin n is equal to n 2 pi x by 2 by 2 plus sin 3 pi x by pi by 2x divided by 3. Then pi by 2 n in the value. Minus sin 4 pi by 2x divided by 4. അതായത് ഈവൺ എല്ലാം നെഗറ്റീവ് ആയിരിക്കും, ഓഡ് എല്ലാം പോസിറ്റീവ്. എങ്ങനെയാ 4 by pi into sin pi by 2x plus sin 2 into pi by 2x by 2 plus sin 3 into pi by 2x by 3 plus minus plus minus sin 4 into pi by 2x by 4 minus sin ഇങ്ങനെ ഓരോ വാല്യൂസ്. ഓഡ് വരുന്നതൊക്കെ പോസിറ്റീവ്, ഈവൺ വരുന്നത് നെഗറ്റീവ്. അന്നേരം B1 സൈൻ, വാട്ട് ഈസ് B1? B1 ഈസ് ഈക്വൽ ടു n ഓഡാണ്. n ഓഡായാൽ 4 by pi, n ഈസ് ഓഡ്. അന്നേരം എങ്ങനെ 4 by pi ഇൻറ്റു സൈൻ pi by 2x മൈനസ് സൈൻ 2 ഇൻറ്റു pi by 2x by 2 പ്ലസ് സൈൻ 3 ഇൻറ്റു pi by 2x by 3 മൈനസ് സൈൻ 4 ഇൻറ്റു pi by 2x by 4 പ്ലസ് എക്സ്. ഇതായിരിക്കും അതിൻ്റെ ഫിഗർ സീരീസ്. ദാറ്റ് മീൻസ് 2l പീരിയോഡിക് ഓഡ് ഫംഗ്ഷൻ. ഓക്കെ, എന്നാൽ ഇതൊന്ന് സേവ് ചെയ്യാം. സേവ് ചെയ്തിട്ട് നിങ്ങൾ എന്ത് ചെയ്യണം, നോട്ടിലേക്ക് പറഞ്ഞു തരാം. ഇതൊന്ന് സേവ് ചെയ്യാം എല്ലാവരും. ഓഡ് ഫംഗ്ഷൻ്റെ എക്സാമ്പിൾ. Next we discuss the Fourier series of a sum of two functions. For example, a function, find the Fourier series of x plus sin x or x plus pi or x square plus x. Then x square plus x ആയാൽ x സ്ക്വയറും എക്സും അങ്ങനെ രണ്ട് ഫംഗ്ഷൻസിൻ്റെ സമ്മാണ്. അപ്പോൾ Fourier series of pi plus x defined in some interval. Then the pi plus x means it is the sum of pi and x. Then Fourier series of x square plus x, Fourier series of pi plus x, pi minus x, etc. That is the Fourier series of sum of two functions. I mean, sum of two functions means to find the Fourier series of x plus sin x. f1 is equal to x, f2 is equal to sin x. Find the Fourier series of f1x is equal to x, Fourier series of f2x is equal to x. That means the Fourier coefficients, a and b are coefficients. The Fourier coefficients of f1x plus f2x is equal to f1 plus f2 in the Fourier coefficient is equal to Fourier coefficient of f1 plus Fourier coefficient of f2. So again, then the Fourier coefficients of sum of two functions is equal to the Fourier coefficients in the sum. Or let f1 and f2, f1 means f1x and f2x be any two real valued functions defined over R. Then if they are periodic functions with the period 2 pi or period L or whatever may be, if f1 and f2 be any two real valued functions, if they are periodic and two real valued periodic functions, defined over R, then the Fourier coefficients of this sum, if f of x, f1x and f2x are any two functions, then the sum is f1 plus f2 of x. Now f1 plus f2 in the Fourier coefficients are the sum of the corresponding Fourier coefficients of f1 and f2. Okay. And then f1x is equal to x, f2x is equal to x square. Then what is f1 plus f2x? X plus x square. X plus x square the Fourier coefficients f1x in the x in the Fourier coefficient plus f2 in the Fourier coefficients. f1 plus f2. That is the Fourier coefficients. Second, that is Fourier coefficients of f1 plus f2 is equal to Fourier coefficients of f1 plus Fourier coefficients of f2. X plus x square, pi plus x, pi minus x, x plus sin x. That is Fourier coefficients. Directly x plus x square and f of x direct pi plus x plus pi Fourier coefficients of f1 plus Fourier coefficients of f2. That is Fourier coefficients of f1 plus f2 is equal to sum of the corresponding Fourier coefficients of f1 and f2. That is Fourier coefficient of f1 plus Fourier coefficient of f2. It's okay? But directly x plus pi plus x. Then f of x is equal to pi plus x. f1x is equal to pi, f2x is equal to x. And in the Fourier coefficients that's okay? Save it Fourier series of sum of two functions. That Fourier series coefficients of f1 plus f2 is equal to Fourier coefficient of f1 plus Fourier coefficient of f2. Save here.